So thanks, Philip, again for the introductions. As Philip said, I'm a territory manager working for the Southeastern Europe market with AWS. And today our topic is understanding cloud economics on AWS. And it's unsurprising on the one hand that many people out there are asking us about how to approach economics when moving with AWS. Yeah, and it's because of two reasons. And the first reason is that simply the cloud has changed the way IT and engineers deliver value. So companies are trying to understand how to capture this value. But there's a second reason. And the second reason is that many AWS customers are being very vocal about their success in financials with AWS. Companies like GE Oil and Gas, Intuit, and Live Nation have achieved massive benefits by moving and running workloads consistently on AWS. And actually, some of them go about telling that people who conclude that the cloud is too expensive are doing it wrong. And then we find ourselves in conversations with many customers that say, okay, why the VP of Cloud Services of Live Nation believes that? When I calculate my cost for the cloud, compared to my server and my storage on premises, the cloud is more expensive. So that's what we'll try to do today. I'm going to walk you through a framework for approaching your migration to the cloud as a first step, but then continuously optimizing the cost of operations in the cloud, and over the course of time, increase the likelihood of your success as a business. So it doesn't just happen like that. That's the main message. And why is that? It's simply because the economics of the cloud are different from any on-premises or co-location environment. Because what we do when we do TCO considerations before moving to the cloud, typically companies look at factors like these ones up there. So they start to look at server costs and storage costs and maybe some networking costs, right? Some of them take it a step further and look at facilities costs sometimes, things like cooling and so on. And the most sophisticated companies I've seen are the ones that try to incorporate some sort of business value in this transition. And they build what you see there as a TCO analysis. But there's a lot more to consider. And let's have a look why there's a lot more to consider in these analyses. Now, you may be wondering what a slide about AWS infrastructure and architecture has to do in an economics presentation. And I can tell you right from the start that it has a lot to do with economics. Because as also Mark said in the morning's presentation, we've built 22 regions with a total of 69 availability zones around the world, network with a redundant secure network. And what happens within each of those regions, and I have a slide here that demonstrates that, is that we have a redundant topology of networking coupled with a set of availability zones, actually a collection of availability zones. And within each availability zone, we have a collection of data centers. So this design is fundamental when you approach economics in the cloud. Because each availability zone sits in a different electricity grid within a metropolitan area, in a different control planning, floodplain, and has, as I said, redundant networking. So think about the following example. You're running on premises two servers sitting next to each other, which is a typical high availability design when building systems on premises. Now, if you build the same design across two availability zones, because we have low redundancy network, the servers are next to each other from a redundancy perspective, but they're not really next to each other from an availability perspective. This fundamentally changes economics when you design systems in the cloud. But the only way to understand that is dive deep, first of all, into this global infrastructure that we've put there, and then understand how this infrastructure affects the way our services are built. Because all our services inherit the properties of this infrastructure. So the global infrastructure matters for economics. And I encourage all of you, and actually I encourage all the customers that interact with us, to deeply understand that as a first step before moving ahead in the cloud with AWS. Another good example is storage. How many of you use compute and storage services from AWS? Okay, quite a lot. So some of you know that as part of Elastic Compute Cloud, our compute service, we offer what we call EBS, Elastic Block Store. And it's actually a service that allows you to launch a virtual disk that behaves as a block device and then attach it to an instance. But then this virtual disk has 5 nines of availability because of that. There's no block device yet to attach to a server and has 5 nines of availability. So it's fundamental when you approach cloud economics to also think how these will behave, how your services will behave because of this topology. So I cannot stress this one enough. And then, as also Mark pointed in the morning in his keynote, it's important to understand the breadth and the depth of the services that we make available out there. Because these services can be creatively recombined to achieve financial results and actually solve problems. And we saw many good examples from Mark and actually Nick from IOLAB area today. But we've also put a lot more out there that solves problems that can promote also successful economics. Let me give you a simple example around security. As you probably know, we make available a number of security attestations as part of running services on AWS, starting from ISO all the way down to PCI DSS, HIPAA, and so on. This matters for economics because to achieve similar compliance status in any on-premises environment, you need to spend a lot of money. And to the context and actually to the extent of the service that we make available to you, we take care of that for you. So that has a huge impact in economics that we need to consider when approaching a TCO in a right way. So the breadth and the depth of services matters. And it matters for another reason that not many people understand and actually realize. As some of you probably know, and I actually presented it last year in the conference, 90% of our roadmap for these services comes from direct customer requests. In other words, it comes from you. So we currently have available out there 165 services that have come to a very large extent from customer feedback. And why do you think customers ask us these services? It's because they want to achieve better economics. So by using these services, you're taking advantage of the collective knowledge of more than 1 million customers running on AWS today that are already achieving better cloud economics by using these. So understanding the breadth and the depth of AWS services matters. And it matters to do so in a meaningful way before starting your journey to AWS and actually as part of the process of designing your architecture for AWS. So I encourage you to dive deep into these, and actually this conference is a great opportunity to understand more about what these services do. And we make available also a number of other mechanisms, such as, for example, our free digital training portal that is available for our customers, different training programs that we have available as part of our training and certification organization, programs for our training partners in different regions, also in this region, as well as help from professional services, also from our partners, consulting partners that are available in different countries. So use all these mechanisms to familiarize yourselves with the fundamentals. The most successful companies I've seen in terms of achieving economics in the cloud on AWS are the ones that are creative, of course, but understand deeply the fundamentals. And then the third thing that matters, and it's obvious on the one hand, but then we again need to dive a little bit deeper into that, is that with AWS, you have available properties of elasticity across many different services. And we encourage our customers to use these properties of elasticity to achieve better economics. Because in any on-premises environment, what we do, is we basically architect for spikes. We try to predict what the next spike of utilization will be, and we architect our environments this way. But then another spike occurs, which puts us into this vicious circle of procuring more hardware and more resources just to try to predict the next spike. Whereas with AWS, we can optimize for all that by achieving elasticity that is inherent in our services, in many of our services. And I'll give you some examples later on. So these three things, understanding these three things is fundamental to approach an appropriate TCO when migrating to AWS. And now that's why you understand that there are a lot more to consider, and actually why there's a lot missing from any traditional TCO analysis that I've shown before. Things like cost-benefit planning, things like workforce productivity and accelerated time to market and value. It's by understanding what the services can do and the global infrastructure can do for you that you can fulfill an appropriate and actually complete TCO analysis. In many of our customers, they try to group the benefits in categories, things like business agility, operational resilience, cost avoidance. And the key there is not to keep it like that as a theoretical exercise, but take it a step further and try to put numbers in these categories in a meaningful way for your business. And the most successful companies are the ones that make this exercise in iterations. So start by doing it as a first step, and then revisit it some months later, and then revisit it again once you're in the cloud. And that's why organizations like Oil and Gas here go about migrating more than 300 applications in the cloud and save $14 million per year in total. So it's by categorizing benefits, looking at the benefit for each category for your business in a granular way, and then looking at all these in iterations. And it's not just Oil and Gas. There are a number of companies out there. We saw some very interesting examples earlier today. Companies like Hearst and News Corp and Novartis. I really like the example from Novartis. Novartis is condensing 39 years of computational chemistry into 9 hours by using AWS services. I'd really like to look at this TCO. Companies like Styria here in Croatia. So Styria, for those of you that were in the Awesome Day in Belgrade, presented how they actually run machine learning on AWS to build a recommendation engine for their readers. And actually how they have achieved better cloud economics by doing so. Right. So let's assume you've done all that, you've built the right TCO, you're moving ahead with AWS, you really like all that. By the way, we shouldn't forget the basics. Once you move to AWS, we always need to revisit how to do things and how to use the services that go about. But let's assume all that. How do you ensure that you only pay for what you need? And that's part of living day to day with AWS and actually optimizing things on a daily basis. Because a fundamental thing that is different from any on-premises environment is that on AWS you pay for what you use. In any on-premises environment you only use what you paid for. It's exactly the opposite. So the objective of sustainable economics in the cloud is actually increasing the usage over time while reducing the cost per unit. And it's more art than science, but I can give you some ideas about how successful companies achieve it. The first thing that we see is that the cloud in AWS has disrupted the way IT and finance work together. Because what used to be the case, and actually Mark illustrated some interesting examples in his keynote today, is that the business had this arm's length relationship with IT, where it was pushing requirements to IT, and then IT was kind of putting together these requirements to write specs and pushing specs to procurement and finance. And then procurement and finance, what they did, they were pushing RFPs to different vendors. So this whole cycle used to take a lot of time, obviously, to come to a conclusion. There was a huge cost of failure. It was hindering innovation, and it's actually slowing out innovation. And it was not producing the right results for the business. So the cloud has disrupted all that. And actually what we see now is IT sitting on the same table with procurement and finance, and actually work around a framework, what we call the 5 pillars of cost optimization in the cloud. And I'm going to analyze all these for you in the next slides. because it's a process that you can continuously implement and have a look at and actually achieve sustainable benefits over the course of time. And it starts by right sizing. And let's look at why right sizing matters when running resources on AWS. Analysts such as Gartner and McKinsey have concluded that most of the capacity in any on-premises environment is more or less 50% utilized. And why is that? As I explained, it's because basically we architect for peaks, right? Depending on the workload we have, we try to predict the next peak, and then as a result, we end up with idle capacity most of the time. So when moving in the cloud with AWS, what we recommend to our customers first is to do also a little bit of right sizing. And the way to do it is actually take a look at your workload, see what kind of workload it is, and then choose the right instance type for the workload. And we offer a number of different instance types that you can choose from, starting from general purpose instances like the M5 instances that many of you use, compute instances like the C5 instances, memory optimized instances like R5, instances optimized for machine learning like the P3 instances. There's a plethora of instances out there that we make available for our customers because our customers request them. So have a look at your workload, and then the next thing you need to do after you pick the right instance for your workload is start from the smallest instance available and do a quick test. So how does my workload behave with a small instance of this family? And then scale up the instance until you realize that your workload can be served in a sustainable way. And then you have right-sized the instance. So more or less you will confirm the statistic then that your instance is on average 50% smaller than a similar environment in your own premises infrastructure. But the beauty of it in the cloud is that you can do this on a daily basis and actually leverage things like CloudWatch and monitoring that I'm going to talk about later to continuously and sustainably achieve optimization. Because what can happen 6 months down the road is that, again, this instance might be overutilized simply because the business has changed. So we should never leave resources unmonitored and actually for a long period of time, right? We need to continuously monitor and implement changes in this environment and continuously optimize. And a good rule of thumb there is to right size first, then reserve. And I'm going to speak about reserve instances later in the presentation. And the second step is applying some elasticity, as I mentioned before, an important property of AWS that we have available across many different services. So for example, in this example here, some of you may be familiar with autoscaling groups. How many of you use autoscaling groups with EC2? Okay, quite a lot of people. So the way it works is, as part of Elastic Compute Cloud, we make available what we call autoscaling groups. And these autoscaling groups allow you to actually build what we call a launch configuration. And then depending on some parameters of your utilization, you launch additional instances automatically. And your workload scales. So in this example here, a spiky workload in the middle of the week would be served by the autoscaling group. And then the autoscaling group would cool down during the weekend, and your utilization would go down. And there are other services that have embedded properties of elasticity, like AWS Lambda, for example. How many of you use AWS Lambda? Okay, a lot of people use serverless here. That's great. So AWS Lambda, as you probably know, scales automatically, and you actually pay for the milliseconds of the execution of the function. It's a service with embedded properties of elasticity. And again, you need to understand that the service has these properties. So I'm going back to the fundamentals of having knowledge about the services before approaching cloud economics. And obviously, we took it a step further last year when we announced predictive scaling for autoscaling. Because what happens there is that autoscaling reads some metrics and then reacts to launch some instances to cover for this workload. But many of our customers had extremely spiky workloads. And they came back to us and said, okay, I need a service that can predict that a spike will occur. So we built EC2 predictive scaling for auto-scaling, which works with machine learning algorithm behind and kind of reads the workload and predicts that the spike will occur to your workload. And this service has been asked by customers that want to achieve better cloud economics. So it's by leveraging these services that you can succeed. And actually, it shows here how it works. We predict the spike, and then we launch the instances through the auto-scaling group to cover for the predicted spike. The third step is to actually pick the right storage for your workload. Just to put it simply there, we offer a number of different storage options and classes for different workloads. And I encourage you to dive deep into all of these and understand what can be done. Things like object storage, EFS as an elastic file system to run file system with Linux servers, FSX for Windows to run file system with Windows, elastic block store that I talked about, and Glacier for archiving. And there are interesting things that you can build and become creative by using these different storage options. For example, how many of you use S3? Okay, a lot of people. How many of you use intelligent tiering with S3? Okay, I see two. That's great. So intelligent tiering works in a way that you put an object on S3, and then you create a policy that if this object is not used for a long period of time, I want to move this object to S3 infrequent access, which is a lower tier storage, and it's cheaper. And then if this object stays inactive in S3 infrequent access for a month, I want to move this object to Glacier. So you can define a policy like that. And Glacier is a low-cost storage optimized for archiving. So again, it's by understanding these services and then using them, creatively recombining them, that you achieve better economics. So I encourage you to pick the right storage option for your use case and actually leverage this in a consistent way. Right, moving to pricing models. So after doing all that, it's important to apply some pricing models that we make available for our customers. And as I said before, regarding reserve instances, the best way is to do reserve instances after you right-size your environment. Because then what happens is that you say to AWS, hey, AWS, I'm going to use this instance continuously for a year. And what we say back to you is, okay, we're going to give you a better price for this instance. But you need to do that after the workload is right-sized, obviously, right? So that's why I stressed this in the beginning. And we make available reserve instances for a number of different services, such as EC2, RDS, and others. And it's important to leverage that as part of your design. So have a look at this workload here. It's a cyclical workload, typical in many use cases, where there is a baseline, but then there are some spikes. And what we advise our customers in these situations is to have the baseline running under reserve instances, because you achieve sustainable financial benefit because of that. So use reserve instances in your workloads in a way that the baseline is covered. And another piece of advice is to leverage what we call spot instance pricing model. How many of you use spot? Okay, I see a couple again. Great. So spot instances, for those of you who are not familiar with them, are basically unused capacity from our Elastic Compute Cloud. Let's put it that way. We obviously have a lot of unused capacity. And we make it available for our customers to actually bid and use at a very low price, which can be, as I say here, up to 90% off from the standard on-demand price. And our customers use spot instances for a number of workloads and use cases. These are typically stateless workloads, such as machine learning, web application servers in auto-scaling groups, and so on. Development environments are also a very frequent use case for Spot. So leverage Spot instances for your environment, because it helps you save a lot of money in this way. And obviously the smartest thing to do is combine all these together. So look at this workload here. There's a baseline that we can have covered with reserve instances. There is a stateful spiky workload, but the best practice is obviously to cover with on-demand instances. And then there's a stateless workload that is also spiky. And then we can have Spot covering that. Many of our customers run entire fleets by combining these instances and actually achieving better economics this way. And let me give you a couple of examples. For those of you, for example, that use Hadoop clusters with EMR. How many of you use EMR with Hadoop clusters? Okay. The best practice from an economics perspective is to combine purchasing options. So, for example, you can run your task fleet, which is stateless, with Spot. And then you can run the master fleet and core fleet with a combination of on-demand and reserve instances based on the graph that I showed you before. So the baseline workload reserved and the rest of the workload on demand. So in this environment, we combine all three pricing models. And it's the best approach that brings you the best results. Another very good example is CI/CD pipelines. How many of you run CI/CD pipelines with Jenkins? Okay, a lot of people. So as you probably know, we have a plugin for Jenkins to launch Spot instances with Spot Fleet. Basically what Spot Fleet is a facility that allows you to launch a group of Spot instances with a programmatic call. And many of our customers use that, especially in CI/CD pipelines and other use cases, to launch entire development environments with Spot. Actually, the usage of Spot is quite a lot on AWS. Just to give you a statistic, the total size of Spot instances running on AWS today is larger than the entire EC2 was in 2013. So I encourage you to have a look at this pricing model because it's obviously very beneficial for many of our customers. Right. And obviously the next step is to continuously monitor and implement mechanisms to monitor this environment, and we have tools there like CloudWatch and CloudTrail and Trusted Advisor. I'm not going to dive deep into this because I could spend an entire hour speaking about monitoring, but it's very, very important as a final step in this cycle to properly monitor this environment. I'm going to give you a couple of examples here. Tagging is very important. So our advice is implement a consistent tagging strategy for your workloads. Tag your resources. You can have multiple tags in resources so that you can track spending in these resources. And then implement a mechanism using AWS budgets where you monitor the budgets for each tag category. And this will give you insights on how to allocate spending and actually triggers about when the spending is going beyond your limits, right? We also made available last year AWS recommendations, which is the tool that our customers really love because it provides recommendations about when to reserve instances and workloads. So we say to you through the console, hey, you can save a lot by reserving these instances. If you want to remember one slide from today's presentation, remember this one. Because sometimes customers come to me and ask, how can I have the best discount on AWS? What is the silver bullet that can make me have the best discount? And the beauty of AWS is that you can build your own discount by combining everything that we've talked about today. So after making your cloud economics right for the migration, that's the first step that I talked about today. What we need to do is right-size instances, apply elasticity, cost optimize, and then measure, monitor, and improve. And there are obviously other things that we can take advantage of, such as serverless, that we've also talked about in the keynote this morning. And serverless technologies, I mentioned the example with Lambda. Serverless technologies help us achieve better cloud economics. And other managed services that we have from AWS. This is an example, this is a real example from an Asia Pacific airline where they calculated their journey based on this diagram. They did real calculations for savings. And they've calculated that their lift and shift helped them save almost 28%. But then they took it a step further based on this model here. And they right-size resources and then they optimize resources on AWS, and they've achieved a total savings of over 55% by doing all that. For those of you that attended the presentation from Styria in Belgrade, Styria achieved 66% by using EC2 Spot and AWS Batch to run their machine learning workloads. And we have other companies in the region. Some of them are global case studies, like Bitstamp in Slovenia, like Bit in Greece, like Upstream also in Greece that is running data warehousing with Redshift, that have achieved similar benefits. And if you ask me what a successful company looks like from cloud economics perspective, this is the answer. It's a company that is growing the usage of AWS while lowering the cost per transaction over the course of time. So you get there by understanding the basics that I mentioned in the beginnings, such as the right architecture and then the broad toolkit of AWS services. And you get there by obviously having the right TCO calculation to move, but also doing things like right sizing, picking the right storage class, applying elasticity, and then choosing the right mechanisms for monitoring. And ultimately, success is paying for what you need and not using what you paid for. Thank you very much. I don't know if we have time for questions. Any questions? Okay, that's great. So the message resonated. Thank you. Thank you very much.